Now it's recording. Thank you. Okay, so simplify inside the function if necessary. I didn't put any on there like that, but you could see those at some point. So as for an example, what about something like this? What if we had a function like that? Okay, if we had some quadratic parent function, an x squared parent graph, and we were doing all this stuff inside the function. Well, that's complicated, right? How would you execute all that stuff inside a function? That would be hard. All you'd have to do is just go ahead and distribute the two and collect like terms. And that's still not super easy, but now we can deal with it, right? Now we know that we've got a combination of a horizontal translation first, right? And then we'd have to horizontally dilate the graph after, right? Okay, so it makes it much easier if you just simplify first. Okay. That's an example of one maybe that we'd want to leave alone though, right? Here's one where this time if we were to distribute the two, it'd make it harder, right? Because this time we've got an x minus 1 in parentheses, and you know, we'll get down to rule 3, I'll emphasize this again. We like that, right? If you have a number that's being added or subtracted from x directly, that's easy, right? Then you just know when you've done all your reflections and dilations, then you're just going to translate it, that finished product, to the right by 1. Right? So you wouldn't want to make that be harder if you distributed there. But this one up here is a lot easier if you simplify on the side. Right? So there's one, rule 0. Not anything that's going to really affect us this year, but in the future it will. Okay, so rule 1, distributive multiplying outside. This can be really helpful. So what if you have something like that? Right? If I've got 2 times this quantity, well, why not just distribute the 2 and get that? That's easy, right? Then I'm going to vertically dilate by 2, stretch it vertically by a factor of 2, and then what do I do to the vertex? Where do I drag this thing? How far? Right 3 and piece of cake, right? Much easier, okay? So always, if you're faced with a situation like that, yeah, just distribute. If something's being multiplied outside, just distribute it, right? So you make it look easier. Okay, next rule. Not really a rule so much, but just a reminder. We talked about this, but just it kind of makes your thinking about this stuff easier. It makes the problems less stressful. If you just remember that all the horizontal and the vertical transformations, everything, that's, reflections, translations, dilations, all that stuff. The horizontal stuff and the vertical stuff are separate. They're completely independent of each other. It really doesn't matter which of the two you do first, horizontal or vertical. It really makes no difference, right? Now, a lot of times when we're talking just about the horizontal stuff, yeah, it will make a difference. Sometimes, as we'll talk about here, sometimes we're going to translate first and then dilate. Sometimes we're going to dilate first and then translate. But when we're comparing the horizontal to the vertical tweaks that we're doing to the function, those we can always just completely separate from each other, right? That make sense? Okay. All right. Question? Okay, rule 3. Translate last if possible, right? So horizontally, if h is subtracted or added, if we're adding it, we're just subtracting a negative, directly from x, where x has no coefficient, so x isn't being multiplied by anything, then that's easy, right? That's an example like that one, or like that one, right? Where there's a number that's being only subtracted from x, or could be added to x, right? Then I'll do the dilation first, and then just slide it horizontally. Down here I did the vertical dilation, and then I just slid it horizontally and vertically, it turns out, right? That makes sense? So if possible, we always want to hold out till the end, right? We want to do all the other stuff first, and if the number is being added or subtracted just from a plain old x, save it to the end and then slide the finished product. Vertically, same deal. If k is added outside of everything, right? Outside of everything, so it's by itself, just at the end of your function, there's a plus or a minus something, you know that that's just the vertical translation, right? Do that last, okay? And you already do that, but we're just kind of organizing this. So for example, if we look at this guy right here, what would the order be? Does it make sense that we're gonna do the horizontal stretch first by a factor of 4, because we're multiplying inside the function by 1/4, right? Then, when all's said and done, then we'll just do our translations. We're gonna 6 right and 8 up in either order. That doesn't matter which one you do first, horizontal or vertical, right? But we definitely want to save those till the end and do that first, okay? So if x is directly multiplied by a coefficient, okay, b, inside the function, we're going to call the coefficient b. So if x is multiplied by b inside the function, and there is some horizontal translation, then you have to use this order. You have to horizontally translate first, and then horizontally dilate and reflect, right, last. Remember that horizontal dilation actually multiplies the distance from the y-axis by the horizontal dilation factor. That's really what you're doing, right? When we stretch something horizontally, what we're really doing is we're stretching it from the y-axis, okay? So for example, if we're, for example, this guy right here, right? What's going on? That's a little different than that one, isn't it? They look similar, but it makes quite a difference that the x is being, or the 6 is being subtracted directly from the x in parentheses here, and it's not here, right? Here it's being subtracted from a 1/4 x. So what would the order have to be this time? What would we have to do first? Good, we have to translate horizontally first, don't we? Translate 6 right, then what? We could go up 8, that's fine. But let's ignore the vertical part for a second. Horizontally, what would we have to do next? Stretch it by 4. Good. So when we stretch it by 4, think what that's doing. So if we're gonna move this thing 6 to the right, and then we're gonna stretch it by 4, that means everything gets stretched 4 times as far away from the y-axis, right? So what would this look like? We'd have it's a square root graph, right? So horizontally speaking, it's just going to look like this. When we do that part, right, we're going to drag it to the right by 6. Now when I do this stretch, everything is going to get stretched by a factor of 4. So that means that this point right here, for example, it's not going to stay there. It's going to get moved out so it's 4 times as far away from the y-axis. See what I'm saying? Everything gets stretched. These are definitely harder to do than those, aren't they? Right? Okay. And then maybe the last, and then finally we could translate up by 8. But once again, we could have translated up first if we wanted to, because that's a vertical thing, and that's different from the horizontal. Right? The vertical and the horizontal, we can do those, we can separate those into any order we want to. But these 2 steps right here absolutely have to be in that order. Right? Those 2 you have to do in the same order, but we could put this one in front if we want to. Okay, questions? So far so good? Okay. One last little hint. This is just a minor thing, but it makes a big difference. As you get better at math, you start to see the value of doing some things like this. Like what if this was our function? This is kind of complicated, isn't it? What would the order have to be in which we transformed that function? Let's just look at the horizontal stuff. Right 6, stretched by 1/3, so we'd be compressing it, wouldn't we? That's kind of complicated, right? This is easier. What do we do here? Well, if I just factor a 3 out of this expression right here, if I just factor a 3 out of that, undistributed 3, wouldn't you agree that we just get that? That's better. What do we have to do here? What would the order be?
Right.
Compress first, when we're just compressing it right around, it gets evenly compressed where the special point at the beginning that starts at the origin doesn't get moved. It just stays put and everything gets compressed around it, right? And then we translate to the right only by 2. See what I'm saying? Okay, that makes it easier. Okay, so I'll put that up on, on the site. you can refer back to it. We're gonna take a couple days just to kind of review. I know it's probably more than we need, but we'll go ahead and do the test Friday. We're gonna take a couple days to review here. The way we're gonna review is with our Friday football fun. Now, let me explain this. So first thing you gotta do,
Do anything funky with vertical dimensions? Like,
no, just the horizontal.
What if you have a vertical one?
Vertical and horizontal
That's the same.
dilations. It doesn't matter which one you do first.
But if you say you know how to become there, you have to do the.
So what if there's, so I think you're saying this, what if there is a, like, what if there was a, tell me if I'm right. What if there was a 7 out front, right? Well, then you definitely would do the vertical dilation before you would do the vertical
Yeah, that's-
translation.
Yeah.
Is that what you're saying?
Yeah.
Does it matter which of these two dilations you do first? No, not a bit. Horizontal and vertical are separate. Okay? Okay, this, I mean, and this is really, I mean, this is probably the most advanced transformation stuff that a Algebra 2 class has done in the history of the world. Like there's a lot of stuff going on here that you wouldn't normally see, but yes, yeah.
So when you're given a graph, how do you, and you have to write a function, how do you tell like what happens first? Was it translated first or dilated? Like, how do you tell?
If you, say it again, if you're given a graph?
If you're given a graph and you have to write the function for it, how do you tell if it was dilated first or translated?
Well, okay, so, good question. A lot of times you can do it many different ways. There's more than one way to get that graph. You probably want to try to just use the easiest one, right? But there would be multiple, if I just gave you a graph and said, what's the transformation equation that would produce that graph? There are going to be literally an infinite number of ways you could do it. Now, most of those are going to be way too hard to think about. But there are a lot of times, like we could do, for example, if I just erase, these two things give you the same graph, don't they? Which one's better? Well, probably that one, but they both work, right? They both technically would be correct. If I just gave you the graph and said, write the transformation function, either one of those would be okay. Okay? They're just different order of steps. Just probably an easier, better order. But I don't know, I mean, not that much. See what I'm saying? Okay. All right, so here's what we got. Grab all your worldly possessions and just kind of move to the side here because you're going to have to reorganize yourselves, get with your groups.